Hope everyone's having a great day so far. I am delighted to introduce Ed Mason from Jet Zero, who is the sponsor of this next session. Hopefully it will be just as enjoyable as the last two. So welcome, Ed.
Thanks, Shahana, and thanks for putting on a fantastic conference, everyone at Bioenergy Council here. It's great. And as an introduction, my name's Ed Mason. I'm the CEO of Jet Zero. Today we've got session 3, just after lunch. We've got an exciting lineup of speakers. We've got Flyn from Fulcrum, we've got Paul from BP, we've got Jennifer from Frontier, and we also have Heather from Gevo. So I'm pleased to say what's exciting about that group is 3 of those companies are all building SAF projects or already have built SAF projects. So we hear grassroots, all the challenges, the war stories that they've gone through to get those projects up and going, and I think that's going to be exciting about this session. So that's the lineup we've got today as discussed. A really good representation of project companies here. I think as an introduction, particularly the session straight after lunch, just a reminder of sort of why we're all here today. I think this tiny planet we all live on, 100,000 light years away from the edge of the galaxy and one of 2 trillion galaxies out there, it's a fairly small and fragile place, and certainly greenhouse gas emissions are probably the #1 threat to a place we all live, work, and have grown up in. And I think specific to the aviation sector, the challenge is very clear. Every year, the sector emits around 1.1 billion tonnes of carbon. Represents obviously a big chunk of the transport industry. It's growing at a phenomenal rate. Even with all the efficiencies of aircraft, we've never seen urbanisation, particularly in the developed world, like we're seeing today. And that's only going to increase going forward. I think to just visualise the kind of problem we have, a flight from Brisbane or Sydney to London return emits around 2,000 tonnes each way, 4,000 tonnes in total of CO2. If you're trying to visualise that in volumetric terms, it fills the size of the GABA or the MCG. And we know there's multiple flights leaving every day. So it's a problem that we certainly care about at Jet Zero. I know most of the companies here do. I've stolen a slide from the BP Energy Outlook. Hopefully I haven't stolen it from your presentation, Paul. But it's very clear. We have solutions across the motor vehicle industry for decarbonisation through batteries. In heavy industry of vehicles, we have hydrogen as a solution. And I think that's potentially why some of the earlier discussions we have challenges around ethanol and E10. They're the adoption methods the governments around the world are sort of following. We then have marine solutions with hydrogen that are very much a focus, and then we get to aviation, and it's quite clear SAF is the only solution. Why SAF's the best solution? Well, it's 7 times still the energy density of the most advanced electric batteries out there, 4 times the energy density in volumetric terms of hydrogen if we are to liquefy it to minus 250 degrees and load it onto planes at every airport in the world. And I think most important, it reduces emissions today, we can use it today, it's safe, it's ready, and it's certified. I think SAF, it's not just a carbon story. I always get asked, when will SAF be the same price as jet fuel? Personally, I don't think it ever should be the same price as jet fuel. Not only does it reduce carbon, we have very little sulphur in the SAF, we have very little aromatics. For that reason, we have very low contrail emissions, and it's got better energy density qualities, particularly for an airline like Qantas flying very long-haul travel. It's a better fuel than jet fuel. So I think they're merits that need to be acknowledged. I think, not to take away from the previous session, we have a really competitive advantage here in Australia with regards to developing a SAF industry. It comes down to 3 areas. We have scale of agricultural industry here. We have great infrastructure, particularly in Queensland, where there's 21 ports up and down the coast, a really big rail network, phenomenal infrastructure, and we also have knowledge. And on our journey with the Jet Zero Australia project, we've been really impressed with the knowledge within the mills, within the agricultural industry here in Brisbane, There's a lot of great bodies that we work with, whether it's SRA or cane growers, that really understand this industry. And I think that's important to sort of acknowledge. This is a noisy slide, but basically this is it. This is the projects under construction or operating in the world today. I think it's interesting, almost all of them are in Europe and the US, very few are outside of it. And if we're to meet the 50 billion litre target for SAF by 2030 or the 500 billion litre target by 2050, we have to replicate what's on this slide every 2 to 3 years to get to those production volumes. It's a huge growth requirement that's out there. I think when we started Jet Zero 2 years ago, I think the outlook for SAF was actually more complex than it is today. We didn't know what the demand would be. We didn't know what the commitment would be. We even had question marks around a lot of the technologies that have since de-risked. And I think it's really exciting to know that forward contracts for SAF demand have never been higher. We have a lot more clarity on the demand out there. We've got great commitments from airlines around the world, including Qantas in the last 12 months on their SAF commitment by 2030, and that makes a huge difference with the opportunity. Challenges, we've talked a lot about feedstock. I work in also the battery metal sector. Australia's known for its mining industry around the world as being one of the leaders. Having worked for some of those companies, it's a hell of a lot harder to find the critical minerals that are required to make batteries in Australia than it is when we look at the feedstock scenario around the world and in Australia for agriculture. Yes, don't get me wrong, there are challenges around feedstock, but it isn't the fact that the commodity or the actual supply of fuel there doesn't exist. It exists. It's about moving it, and it's about working with business models along the supply chain that need to evolve and potentially take on some risk to grow with this industry now. Technical pathways, there's several out there. We've heard from some of them today. Gevo, one of the leaders, along with our project partner LanzaJet and Alcohol-to-Jet. I think it's important to acknowledge that a lot of technologies now out there are at TRL 6 or 7 or above, and in the next few years will really de-risk and potentially provide solutions to lower the cost of SAF going forward. Policy positioning, very important. I think the transition's here, whether we like it or not, to SAF. It's going to happen. The biggest challenge is accelerating it at the pace we need to develop the 2 to 3, the group of projects we saw on that earlier slide. And I think policy should be really focused around the developing the industry, more so than necessarily what the outcome of SAF is long term. And I think what the Bioenergy Council have done, what our project partners are doing at the federal and state level really helps. A little about Jet Zero and our company. We're a bioenergy company. We were established a couple of years ago to produce SAF from domestic agricultural waste and byproducts from sugarcane. We think there's value in that, in the sense of focusing on crops that are the best sequesters out there versus other feedstocks. We've focused on a diversified feedstock model, focused on both milling and farming, but importantly encouraging growth in feedstock, and whether that means we're investing upstream, whether we're helping our partners grow feedstock, we're talking to as many as we can to do that. As an energy company, we've had the luxury of choosing what we think is a de-risk technology. We've chosen Alcohol-to-Jet to convert ethanol into jet fuel, and that's culminated in our partnership with LanzaJet, and they are building a plant right now in the US. And on partnerships, which we've heard a bit earlier, we've worked hard not just to build the partnerships we currently have within the business, but also other bodies and other areas of the supply chain. Our business model is pretty simple. We're looking at sourcing low carbon intensity ethanol, first-gen ethanol. We're focused on the upgrade, purely that step of the supply chain into jet fuel. And then I think we've done enough to de-risk everything to the right of that slide with regards to blending partners, airport distribution, and then with the coalition members of Qantas, certainly got strong support for the demand of the SAF that we need. Just to flag, we've got a board that's had a lot of experience in biofuels, financing projects across the energy supply chain, and also engineering. We have a project team here, many of them, in fact all of them are here today, so feel free to reach out, that has a very strong experience in developing and operating refineries and bioenergy plants. And without those people, we could not have achieved what we've done over the last 12 months, and it's important to sort of acknowledge that. Our partners involve the Queensland Government, who really kicked off our business with a grant, and while it was moderate, it enabled us to then go and raise significant capital by institutional funds alongside that to get through all the study work. Qantas and Airbus then came in as investors, but while the investment was crucial, I think their counsel and how we're working through the various challenges around policy, sites, etc., has been invaluable to where we've got to today. LanzaJet, we have a heads of agreement with LanzaJet and Qantas to build a plant here in Queensland. They've been instrumental in our study work to date. We spend a lot of time with millers along the east coast. We also talk to suppliers of ethanol down south, and importantly talk to a lot of the industry bodies just about where we're going and how we can potentially align to what they are trying to achieve. And I'm glad to say we're also working in these initial stages with two engineering groups here out of Brisbane, Long Energy, Keith Sharp's team, who's being a big promoter of this conference for some time, and also Long Energy as well, and our offices from the project side are all based here. And I'm pleased to say we're also starting to engage larger EPC groups for the actual bigger project. We haven't disclosed the site location yet. We're completing all the sort of permitting and feasibility work, but we hope to do that shortly. Needless to say, it will be in North Queensland. On the right is a photo of a site that's about a third of the size of ours. It's currently under construction in Georgia in the US, and our project will be almost identical to that in its design. As I said, I don't think all SAF's the same. There's various production technology pathways. We think the abundance of ethanol that could come from the biomass feedstocks in Australia is significant. We like the technology, the efficiency of it with LanzaJet. Importantly, it's certified, and for that reason we think there is value in that, not just from an environmental but a social side of things. We're relying heavily, as I said, on our project partner. Why we were fairly excited with the partnership with LanzaJet was they are building a plant and commissioning it as we speak in Georgia in the US. They have very strong backers. We expect some technical teething issues as this is commissioned over the next 6 months, but importantly we're very confident that they're going to get this plant up and running, and it will be the first of many alcohol-to-jet plants that we'll see. And I'm aware Gevo are also doing similar things in the US at a dramatic pace. Our strategy really was always just develop the industry, get it off the ground. We've sized a plant that we think is suitable for the availability of existing ethanol in this country and potentially new sources. And with that plant developing, we can then start to scale and start to bring the cost down. I'm pleased to say it's taken 2 years to get to the point with Qantas and Airbus to announce this first project, but we've been working for several months on other projects. And I think over the next 12 months really can get on a path to start to meet that 500 million litre demand that Qantas need for what they've committed to for 2030. And that's it as Jet Zero. So I invite Paul.
Thank you, Ed. I'd first like to acknowledge the traditional owners upon the land in which we meet and pay my respects to their elders, past and present. So I'd like to thank Graham in the previous session for drawing the connection to feedstocks that address environmental problems, because that's exactly what we do. And when I explain who Fulcrum is, I like to, one of the first things I talk about is the two environmental problems we're solving. We take garbage or trash or whatever you want to call it and convert it into sustainable aviation fuels. So we're helping decarbonise the aviation industry and we're getting waste out of landfills. And that second point is often somewhat overlooked sometimes. And you consider landfills, they're unsightly, odour, litter, they produce a lot of methane, and if not engineered right, can lead to soil and groundwater problems. So really important point to remember. So just a quick bit of history on Fulcrum. We were founded in 2007, based in Pleasanton, California. In that time, we've brought in a large and growing, I guess, stable of both institutional and strategic investors that funded our growth and development to date. We've financed, constructed, and now operating our first facility just outside Reno, Nevada, and I'll show you a lot more about that in a moment. And we now have 3 other projects in the various advanced stages of development. So the next being up in Gary, Indiana, which is a project I've been working on for the past 5 years, a project down on the Texas Gulf Coast, and then we also have one in the UK as well that's fairly far along. And underpinning all that, we have master feedstock MSW supply agreements with 2 of the largest waste haulers and landfill operators in the United States. And then at the other end, offtake agreements with a number of our strategic partners like BP, Air BP, United Airlines, Cathay Pacific, Japan Airlines. So importantly, we haven't, as I said, we haven't done this alone. Our group of investors is growing by the day and it's pretty broad and diverse at this stage. And if you look at the ones on the right, we have a group now that represents the end-to-end value chain of what we do from feedstock and MSW supply all the way through to offtake. So just a quick bit on our process and the technology. First thing to understand is we are not a technology developer. We've not developed any of this technology ourselves, nothing novel or new here. We've gone about and licensed existing proven technology and integrated it in a first of its kind application. Really, it all starts with feedstock processing and you know, we have what we call a feedstock processing facility, a very original name. But that's very similar to a recycling centre or a material recovery facility. It's one of the most fundamental parts of what we do because most biofuel processes like homogeneous feedstocks. Waste is not homogeneous, and so we have to first sort the material into what we can, into a feedstock that is appropriate for gasification. So we're pulling out all the things in the waste stream that don't work, inert material, metals, rocks, gravel, glass, that sort of stuff. At the end of that process, we have a feedstock that we shred and dry, and then it goes to our refinery, our biorefinery. First step there is a gasification process. This is a piece of equipment that we have licensed from TRI. It's a large steam reformer with a few other bits and pieces bolted on. That breaks the material down into a synthesis gas or syngas. We then clean that up, removing any impurities. So what we have is a very pure syngas that goes into our FT reactor, and that's licensed from J.M. Davy. That produces an FT liquid or a syncrude or a biocrude, whatever you want to call it, which we can then upgrade hydrocracking, etc., into SAF and other low-carbon transportation fuels. All of that pulled together, we can produce a SAF that delivers at least an 80% reduction on a life cycle basis compared to conventional fuel or jet fuel, and we see a pathway, a very achievable pathway to getting to net zero or carbon negative fuels with the add-on of things like renewable power and, if depending on the location, carbon capture and storage. So just a quick bit about Sierra. So this plant, as it's built, has a production capacity at full capacity around just under 40 million litres a year. To produce that, we'll be processing 500,000 tonnes of waste a year. A really important thing to understand with Sierra, it's not yet producing SAF, it's producing syncrude. We stopped at SAF intentionally. It's our first plant. One less thing to commission and start up, make life a little easier. That is, for the time being, going to Marathon Petroleum, and they're co-processing it in one of their refineries on the west coast into fuel. But Sierra has the space. It was designed with upgrading, and it was permitted as such, and in the coming years that's hopefully what will happen. As you can see, Sierra wasn't developed overnight. It was a long and arduous and sometimes very bumpy road, but last year was a very pivotal milestone both for the company and the project when we started operating the plant. At the end of the year, started producing our first gallons of syncrude. So just a bit of a show and tell. So this is what our feedstock processing facility looks like. It certainly looks like nothing unique or special. It's a large shed with a bunch of processing equipment in it. Looks very similar to a recycling centre or a material recovery facility for those that are familiar, but a really important part of our operation. This is what it looks like inside. So it's all largely automated processing equipment that's sorting in sequential steps, sorting and separating the material, doing density and size separation. We've got magnets and eddy currents ejecting metals. We've got optical sorters ejecting some of the plastics, and then what we have at the end is a carbon-rich feedstock, timber, textile, paper, cardboard, some plastic that we shred and dry that is appropriate for gasification. So this is Sierra as it stands today. The photo on the left is looking at the gasification structure, or the gasification island as we call it. And the photo on the right is looking at it from the back. In the foreground, you've got the pipe rack and some of the gas cleanup equipment. A side-on view shows, again, the gasification island and the pipe rack and more of the gas cleanup equipment. And then towards the back there, you've got another structure, and that's the FT structure. So that's where the magic happens. And proofs in the pudding. So this is our CEO with one of our engineers with a sample of the first first product that we produced at the end of last year. I had the good fortune of being at the site, I think the day after we first started producing, and there was certainly a lot of smiling faces that day or that whole week. So where to next after Sierra? So we have a fairly ambitious development and growth program of projects, certainly across the United States. These will all be projects that are 3 times the size of what we built in Nevada. So a modular 3 times scale up, 3 gasification structures side by side. The next is our Centerpoint project up in Gary, Indiana, as I said earlier, followed by Trinity on the Texas Gulf Coast. And we also have a project, same size and scale in the UK that we're working on too. And then there's obviously a vast, several other locations in the US that we will be looking to go to after that. This is what those plants will look like. So this is a render of our facility as it will stand up in Gary, Indiana. And as you can see, 3 gasification islands side by side into a single gas cleanup and FT operation. Gary, Indiana is a great location for a project like this. A very industrial town, a lot of great infrastructure, BP Whiting's refinery is just up the road. So a lot of really good synergies next to Chicago, O'Hare Airport, United, another really important partner of ours in their main hub. So this project will produce around 120 million litres a year at full capacity, process, supported by 2 feedstock processing facilities, which will process a total of around 1.5 million tonnes of waste each year. So not an insignificant amount and pretty complex operation, certainly on the feedstock processing side. And we hope to break ground on this at some point next year and be operational by the end of 26, early 27. So that's where I'll leave it, and I look forward to answering questions later.
Hello again, everyone. So great to hear from Fulcrum. I remember talking to Fulcrum a few years ago in the UK around Sierra. So great to see that these guys are up online, and it shows the progress that we're making in the industry. This morning I spoke about BP's global biofuel strategy and a little bit of the opportunities that we see in the strategy here in Australia. Now I would like to turn a little bit and talk about Kwinana Renewable Fuels project, what we like to call KRF, and it's great to be in a session that is titled Global Leaders and Domestic Champions, specifically around the domestic champions. So I feel very proud that BP is really taking a step to move the bioenergy industry here in Australia. Before we go into a specific about KRF, I think it's worth to cover a little bit of the history that we went through in Kwinana, and also I think shows the opportunity that we have in the bioenergy industry for our country. So it emerged out of a challenging time for BP Australia, and we made the decision to close the refinery in 2020 to become an import terminal only. And at that time, we also began exploring other viable options for the refinery and for their assets. For those that don't know, Kwinana is about 40 kilometers south of Perth, and is one of the biggest, most active industrial areas in Australia. BP Kwinana has long and proud history with WA and has provided jobs for generations of locals. We got sons, parents, and grandparents that have worked in the Kwinana refinery for 3 or 4 generations. And it's a valuable site with existing infrastructure that is connected to fuel distribution network and is a central pillar of WA fuel security. Highly integrated to the broader Kwinana industrial site, and the area, if you haven't been, is an amazing area. Over decades, different heavy industries have developed alongside each other, leveraging commercial synergies. Inputs for one, produced by another, waste from one, useful for the next. And like BP, many of our neighbours were looking to decarbonise, and we feel KRF can help to do that. So our vision for an integrated energy hub emerged out of the 2020 closure of the refinery that would continue to import the liquid fuel, maintaining the state energy security, but also will leverage the infrastructure of the former refinery to produce renewable fuels, providing much needed decarbonisation fuel to WA and beyond. With KRF also being the first off-taker, as I said earlier today, for our renewable energy hydrogen project that could also supply clean hydrogen for any number of industrial and transport customers, and also to the broader Kwinana industry area. And it's a great proof point of the energy transition in action, where one part of the puzzle unlocks opportunities for other projects. And we're really excited about this opportunity as we move beyond concepts into concrete projects. And that is exactly what we're doing in Kwinana, moving from concept to concrete projects. And I'm pleased to say, as said earlier today, that last year we entered the front-end engineering and designed for KRF, and we're really optimistic that by the end of the year or in a few months, we will move into final investment. We will make the final investment decision for KRF. KRF is a major investment for BP. So as we announced, we're looking at around $1 billion Australian dollars investment, and it will be a 10,000 barrels a day facility producing renewable diesel, sustainable aviation fuels, and bio-naphtha by 2026. And we will be providing decarbonised fuel to our customers while providing sovereign fuel production capacity. Earlier today, I talked about BP's plans for 5 biorefineries globally. And as a global company making capital decisions about investments across the world, KRF will need to compete with other projects. It is advantaged by its ability to integrate with existing wharfage, tankage, pipelines, and terminal operations, including into the Perth airport, allowing KRF to add locally produced decarbonised drop-in fuels to BP's existing importation, storage, and distribution system developed for conventional fuels. While KRF has all the existing advantages, it will be competing for capital against other projects in countries that have strong existing demand that is supported by targeted policy. KRF is based on the processing of HEFA, and please don't ask me any technical questions later today. But as the technical people will tell me, HEFA is a term that converts biofuels from used cooking oils and beef tallow, amongst other things. And we anticipate a combination of both domestic and imported feedstocks being used. KRF will be designed to accept a broad range of feedstocks and with flexibility to optimize between different fuels it produces. Flexibility to optimize the operations in response to feedstock availability, prices, and demand for the end products will also be an important factor for the overall economics and success of the project. Having policies and systems in Australia to support biofuels will help. High sustainability criteria that is right for Australia, certification system that allow for commingling of feedstocks as part of the production and allows for biofuels to be supplied commingled with a fossil alternative. Another ingredient for the success of the project will be securing demand, and a lot has been discussed today around demand. We've already heard about the increasing ambitions of other markets and the increasing incentives underpinning this demand. We also see great potential for renewable diesel in mining and other heavy transport as sustainable aviation fuels for the aviation industry here in Australia. But there is a substantial premium for these fuels, and without the incentives that are offered in other markets, there is a real risk that any fuel produced in Australia will be exported to those markets. While KRF will be designed so they can export the fuel it produces, it will be preferable if there was firmer domestic demand. We don't want to see a situation where our fuel is exported to other markets in response to incentives. For example, fuel flights that come back to Australia. We really need policy to drive domestic demand. This is an exciting time to be talking to all of you, as I said earlier today, and I'm sure, like me, you share the feeling that we're taking a big step forward into the future, into we will be providing real solutions for our customers on the road or the flight, in the case of Qantas, to a net zero world. Thank you very much.
Hi, everybody. Pat Gruber here. I'm going to share my screen. Hang on just a sec. There we go. Well, it's a pleasure to be on screen with you. I wish I was there with you. It's such a wonderful place. Today I'm going to talk about Gevo and what we're up to. And our basic story is we're all about net zero and carbon negative fuels and chemicals. It's a huge potential market. We've been at this for a really long time, started in 2007 doing alcohol into jet. And our little plant over here in the middle of the page here, that's been operating since 2011 making jet fuel. And we've been selling it since 2016. Oddly enough, believe it or not, I think we're like the third largest plant in the world with our little tiny 100,000 gallons per year capacity. So it'll be good to see everyone else scale up. The net zero site is what we're working on currently, developing it and working on financing of it in Lake Preston, South Dakota. This plant is unusual, and it's going to be an alcohol to jet plant that'll have the capability of driving below net zero. We also have an RNG facility. So we're busy. And we view it this way. You got to grow. Photosynthesis, we believe, is the very best way of capturing carbon from the atmosphere. It uses 10 times less energy than doing a direct air capture of CO2. Makes carbohydrates. Carbohydrates made alcohols. Alcohols turned into olefins and fuels into chemicals. Now, this alcohols to olefins is a big deal. Our partner Axens has been working on this. They have a 50% market share in the petrochemical industry of converting ethylene into jet fuel and diesel fuel and other such things. And so we have our own technologies, but as we looked at it, we said, gee, you guys make a good partner because you already have big, giant commercial plants operating. And so we like that. It makes it more, it takes away a lot of the risk that one would have with a brand spanking new technology. They also have a plant that does dehydration of olefins operating in Japan for over a year now. And so we like it. It de-risks the whole project. So we wound up partnering with them. We aren't real proud. We work with people who ever have technology. Because they're olefins, they also go into other chemicals. This is a chart. I think we're going to be sharing these things, but we've been at this jet fuel stuff for a really long time. A couple the ones in blue here are things where we had the first, one of the important ones in 2017 with Virgin Australia. We flew 1 million kilometers with jet fuel. We're also the first to make jet fuel from wood and cellulosics. We've also made it from molasses and cane sugar and everything else too. Any carbohydrate works. So point of it is this stuff really is capable. It can be done. It is just jet fuel. And it's all about driving the CI down and driving the cost out. This is just some of the things that we've done around the world. The basic concept is this. The top line is oil comes out of the ground, you use energy to process it, you burn it and make CO2. Of course, when you do photosynthesis, it captures CO2. You want plants that have good roots, and you want, if you're using farmland, you want to grow protein first too. And then if you use non-fossil based electricity and steam, you can really drive the footprint to be quite negative. Here's how this works. A typical jet fuel might be a 90 CI score. CI is the measurement of carbon that's emitted. Ethanol might typically have a 71 score in the US. It takes about 24 CI points worth of energy if using grid electricity, grid gas. You get about 24 CI points. And so that's about 95, just grid stuff, gas and electricity. So it's a simple problem. You decarbonize, defossilize electricity, that's worth 18. Using the technologies that we developed and patented around how you integrate and do some of these chemistries, you get down, subtract off minus 36 points, minus 5 for green hydrogen. For sequestration, which is the capture of CO2 that comes off the fermentation, that's worth about 32 points. And then how you grow stuff matters a lot. This is worth minus 30 here in agricultural practices, so it gets to a minus 26 overall. This has been published by Argonne National Laboratories. Here's a list of the different feedstocks that we have worked with over the years. The residual starches and the simple sugars, they're definitely the easiest. We'd sort them out by sustainability and cost as to which ones we like. The cellulosics and all that, they work, they just cost more to obtain. So they have a future potential. And of course, these bio-based fats and oils are the HEFA type, and there's other routes. Now, one of the key things that we run into all the time is people ask us, what about land use? It's like, hey, land use has actually stayed the same here in the States for the last 100 years or decreased. And you know what? The productivity of all the crops growing are increasing. And so when you start to think about really big systems and what can work, we're starting here in the States using corn as a feedstock. And here's why, is that we have an overabundance of carbohydrate here in the US. Well, carbohydrates don't contribute to nutrition. They make us all fat. And corn is one of the most prolific crops to grow protein. That's actually why it's grown. Most economists miss this point. But in fact, that is what happens. In fact, a net zero 1 plant like we're designing would actually produce more protein on a tonnage basis than it would jet fuel. It also is about as good on a per acre basis as making oil. Most people don't know that. And none of the corn we use is for food. So this is another thing we always have to address when we start talking about what we're doing. We picked corn sugars because they're the cheapest carbohydrate source in the world. They're cheaper than molasses, cheaper than cane sugar, cheaper than any other type of sugar. That's why we're starting here. It does, though, enable us to take in other cellulosic sugars. And there's plans to do that with our partners like with Praj. Anyway, the corn you eat is not the corn we use. Only 1% of the corn is the sweet corn, popcorn, white corn, or stuff that shows up typically in a tortilla. And that's at a key important point, is there's lots of confusion. And this is a fundamental point across all of us who are doing renewable resource-based feedstocks, is it's all about the whole sustainability profile and how the product is used, how the land is used, and how we keep track of things and prove it. We are huge believers in field by field tracking. There's too many games that have been played so far in all this space. Here's something for you, is that conventional tillage is on the left, and if you use strip tillage, which is the way that's being done here in the States, it's growing very rapidly. You get to a minus 27 CI score on SAF or better, and that's actually the whole life cycle, including all the farming practices, all the stuff that goes on, the soil carbon and all the rest, plus then burning it as a jet fuel. And if you do no-till, it's even better. These technologies of how to improve agriculture are not anywhere close to being done. Yields are improving, inputs are decreasing, techniques are advancing. Right now, farmer would not sell you the residuals of the stalks and leaves. They need that to go back in their ground or to feed it to their animals. They will fight you for it. So it's just one of these things that is, stuff's evolving and technologies are evolving. And we're going to see that. I think it's going to be a pattern around the world. We are putting together the whole of the integrated process and designing the plant. I have a big team of engineers, and we work with a lot of other people, Fluid Quip and Praj, who are doing the carbohydrate and ethanol technologies, along with my own set of engineers. And then we use Axens. And as I mentioned, Axens is got tried and true proven stuff, and we know that their stuff plays because we're doing work with a lot of strategics, and they think it plays. So that makes us feel better, and we like it. This is now in the financing phase. We've done the FEL3. It's about doing cost optimization and optimizing. One of the interesting things is that we're able to cut gas use in a plant like this down by 70%, which is pretty darn amazing. And that's through modern design and full integration. Our Net Zero 1 plant looks like this. It'd be this climate smart carbohydrate feedstock. It comes from corn. It is done and be measured at the field level as to what actually happens. It goes in, make carbohydrate, ethanol, alcohol to jet. We'll be using RNG. We have an RNG plant. We can use that to help drive the footprint down. And then we partner with 06 Energy, who does wind and hydrogen. It'll be a 100 megawatt wind farm. It produces about 65 million gallons of hydrocarbon fuel, 60 million of which would be jet fuel. And then it would make 695,000 tons of animal feed and corn oil. We also capture carbon. So that's actually about 1.4 billion pounds of protein product. It's mind-boggling. Verity Tracking is our business. Verity Carbon Solutions is a business of tracking carbon. We're starting this already working with ethanol plants in the US and tracking from the field forward. And the idea is to document everything, put it onto DLT blockchain so it can't be messed with. It'd be auditable, traceable, immutable. And we intend to create tokens, or think of them as sustainability certificates that you just can't mess with, and they'll be super well documented and audited. And so that will track everything throughout the chain. So no game playing. We believe that that's what future world looks like. It's what customers who want brand are trying to protect their brand. They're going to want to know, did you increase land use? We can take pictures and attach it to it. No, we didn't increase land use. Did the farmer go in the field how many times? Well, we got all their plow data and documents. We can do that. We can show that the chemicals that go on the land, it's traced and recorded directly from tractors. We can do this, what kind of electricity was used? What was the mix? How much wind? How much grid electricity if we used for some reason? How much natural gas versus biogas? All those things we can track and report and attach to the fuels. That's what's going to be important. This also works with cellulosics. We're working with our friends in India on this. We've actually had natural gas companies wanting to work with us because we can show how they can reduce their footprint. We've actually had some of the big oil guys come to us and say, can you track it from the wellhead? And heck yeah, this technique works. We're at the stage of commercializing this. So it's going to be an important technique that goes along with this whole business. Stops the game playing. Now, this chart I put in here for you guys, because this is an issue particularly in Australia, is that on the left side of the chart, you have the price of Petrojet. You got a basic cash cost from something like ours is a little bit more expensive than the Petrojet. So our basic ATJ full cash cost, fixed to variable cash cost, is a little bit more expensive than Petrojet. But then you need capital returns. You got to pay, if you do project financing, you got to pay off the debt. So that gives you a stack of costs that you got to cover, and they have to have a decent return attached or no one's going to build it. That's reality. Now, on the right side of this slide, I'm trying to convey this. The light blue is revenue from government programs. If it's larger, well, then it takes less money from the customers. Well, the customers are airlines. Airlines are not always, they don't have big balance sheets. So that's a big deal for them. And it's a huge amount of cost to them to acquire an expensive fuel. And of course, if the government subsidy is small, that means it costs the airlines and then consumers directly a heck of a lot more. And this is one of the problems, is that jet fuels, all of them, HEFA, alcohol to jet, they're all more expensive than Petrojet. And that is the nut to crack if you want to see commercialization. The projects have to get paid back and get returns, or investors won't do it. They'll dabble, they'll look at it, they'll think it's cute, they'll do a little small thing, but we're trying to replace billions of gallons. That means it's got to have a reinvestable, a model that enables reinvestment. Hugely important. Bottom line, as we think about things, this kind of sums her up. Our point of view is that got to have the economical drop-ins made with renewable carbon, and that's how you get the lowest footprint. You got to use defossilized energy wherever you can. That helps drive it even negative. You have to do this accurate carbon accounting thing. This is one of the areas I worry about, because there has historically been huge game playing. It continues to have game playing. I think the only way we stop all this debate with Enviros is to just collect all the data and report it transparently, make it all visible and auditable and available. Not everybody's comfortable in doing that. We are, and that's the standard we're going to set. And then importantly, you got to have these very scalable, reliable production technologies. Newness, we're not fans of newness. We're working with a lot of existing technologies, putting together, optimizing them. We like what we're doing because we can go look at it in real life plants, big scale plants, and see it operating. And so we like that. Putting it together, driving it down, and then making lots and lots of plants around the world. Thanks.
Hello, I'm Jennifer Lauber Patterson. I'm from Frontier Impact Group, and I'm really excited to share you the story of FutureEnergy, Australia's FutureEnergy Park, which will be hopefully producing renewable fuel by 2025. Frontier Impact Group has been in the climate solutions space for nearly 30 years. That makes me sound really old. But over that time, we've been involved in a lot of technologies associated with the energy transition. And one area that we felt was really missing and lacked a lot of focus of was in the liquid fuel space. And I think it still is. However, I'm really excited to see the technologies and the organisations that are here and presenting on their technologies, because it does give hope for the future when you see these amazing pioneers that are doing great things overseas and in Australia. What I love about the project that we are developing is it not only produces a drop in renewable fuel, but it helps in land regeneration. And doesn't that sound weird? Because a few years ago, bioenergy was destroying the planet and the trees, wasn't it? But we're now changing that narrative. And that's actually now one of the positives for bioenergy. Because if we can produce fuel, help with land regeneration, and help with improving resilience in communities, isn't that a win in many ways? And one of the reasons I'm so passionate about it, I've been passionate on climate solutions all my life. But what I worked out was the size of the area that we're covering on this plant. To get the same carbon benefit, we would have to use 50 times more land if we were doing a solar project. So that just highlights the wonderful opportunity that bioenergy brings. So we've been in the fuel space only the last 6 years, but I think that almost makes us fossils in Australia, even in this sector. One thing we did do back in 2021 was develop Renewalium as a brand. And why did we do that? Because everyone was getting confused about 100% drop in diesel, which wasn't the experience in Australia, with a biodiesel and a blend. And I think both fuels can play a really important part. But there's some areas that renewable diesel that's drop-in can really play, that can really help some of those hard to abate sectors. We've heard a lot about road transport, but we haven't heard about, what about the agricultural sector, the farmers who don't transition, that won't be transitioning quickly on electrification. Some will, but some farmers, they'll say, look, when we buy something, we want to use our diesel for the next 30, 40 years. We don't aim to replace our equipment that often. What about the mining sector? What about the construction sector, the off-the-road equipment? And there's a lot of research that's been done by the construction sector and reports that shows that renewable diesel needs to be part of the solution if we're going to move to net carbon zero. So it really is a critical piece of the pie. So the FutureEnergy Park is in Western Australia, and we were fortunate enough back in 2021 to enter into a joint venture with Kwinana Energy. It's really great to see the oil and gas sector coming into this space. I think it's really going to be important to see players such as that coming into the sector for us to have a successful energy transition. Frontier Impact Group, as a partner, we're responsible for the project development and getting it to financial close. And Kwinana are providing their construction expertise and operational expertise in order to manage the plant whilst it's operating. This is a diagram or a picture of our proposed Narrogin FutureEnergy Park. It aims to produce 18 million litres of renewable fuel. It will produce over 8,000 tonnes of biochar and also 6 million litres of wood vinegar. Now, it's really important because the economics actually don't stack up on its own if you just look at the renewable diesel. We need the biochar and we need the wood vinegar to make the project viable. Just looking at why we've gone down the path of this technology for Narrogin, because it is about what we have found. There are a lot of different technology solutions, and all the ones I've heard of today all play an important place as a solution. Why we like the technology we have is for a number of different reasons, but it is for the economic benefits in the particular region. First of all, what we believe, and we're going through a life cycle analysis which will be completed later this year, we believe it could be, and I'm going to put a disclaimer up there because I don't want to get into trouble with any greenwashing, but it could be net carbon negative. But if not, it's really going to be a low carbon solution. And that's because of the biochar that can be utilised and sequestered in as a soil or embedded into other materials. It's a circular economy model. And we'll talk about that more in the next couple of slides. But what we love about it, it is using resource in the community, processing it in that community, and there's the opportunity for us to be able to sell it back into the community. That is the objective where we would like to get to. We're using underutilised biomass resources. So at the moment, in our first stage, we'll be using agricultural residues from the local community that's currently being burnt. So that is emissions. So we're avoiding those emissions from occurring. Or in some case, it gets pelletised and it's exported overseas as a low quality feed for animals. So being able to repurpose this for the production of renewable diesel and other valuable byproducts is an important focus for that community, and we're getting so much support from the Narrogin community as a consequence. The regional growth aspect of it, the jobs, and I'll share a bit more about that shortly as well. And the fuel security side, it makes sense to have fuel where the actual food is. That helps in food security as well. So that's really important. And I loved the media release that Shahana sent out earlier today on the whole energy security side and how we don't want to see the issues of the past repeated. I'm frustrated because I have been in the energy sector for 30 years. And I was there when there were warnings about we need to invest more in renewable energy or else we're going to have an electricity price crisis. And guess what? We have had an electricity price crisis, but it's not because people didn't know about it. There was just nothing being done. And it was the same about the gas sector. Everybody could see, well, the specialists could see what was going on, but we didn't take the right action. What I would like to call for is that this information that's been presented, that it is listened to and acted on, because I think it's really important, because I'd hate to see history repeat itself and for us not to move, because we need the investment now if we're going to achieve our net carbon zero reductions. And at the moment, companies are having to import renewable diesel, and that is expensive, and that puts us at such a competitive disadvantage. So how does this process work? Well, we can use agricultural waste, which is the first stage of our process, which will produce 18 million litres. But we're also looking to use oil mallee. That was mentioned earlier today. So shelter belts. It's not substituting food production, it's actually aiding in food production. So what we look at is putting these shelter belts in areas where it helps in land regeneration, but we can composite and use it also for fuel production. So initially it'll be 18 million litres, but then we'll have at least another 50% increase just from that oil mallee, and that can continue to grow because that 50% increase comes from oil mallee plantations that are already there that can be utilised, not ones that need to be grown, but in the future, that's what we plan to do. It's a high temperature pyrolysis system, and it does have some waste heat that's used to actually reduce the energy that needs to be sourced externally, and then it produces a number of outputs. The renewable fuels, it can also be upgraded to a sustainable aviation fuel. It produces the biochar, which is fantastic for land regeneration, but also for something else, which is another important piece, is graphene. And what graphene can do is going to change the materials industry. So that's another area that I think is important to highlight. The wood vinegar that aids in the nutrient uptake in plants. So it reduces the need for fertilisers. Now, with the big cost of fertilisers at the moment, that's a win-win all around. And then it's a net producer of water as well. So why this technology for Narrogin? Because I do think we need to suit the technology to the actual location. Why this particular location? It's the access to the type of feedstock that we're accessing, the agricultural waste, the oil mallee, the other opportunities that this system can produce. Also, what we like about is ability to scale. So we start with the agricultural waste streams and then we can add on as we get more biomass and we can contribute to grow because it's on a modular basis. What I also like, and it's important, is that it's close to where the biomass is. One of the biggest costs for a project is the transportation of biomass. So if you can be close to the site, it is incredibly price competitive. And so what I believe is we need about 55,000 tonnes of bone-dry biomass a year for a minimal size to work. So we should be able to get that within a 100-kilometre radius, which then gives us a really good competitive advantage when it comes to the feedstock. What we can then do, once we get our first foundation project up, we can have these right across the wheat belt and other parts of Western Australia. So it is competitive because of that, and it also supports that circular economy. It gives back to the landholders, gives back to the farmers in terms of the byproducts. And the exciting part is, as we mentioned before, it can be scaled up to SAF, and we are working with a group that are going through that certification process at the moment, which is pretty exciting. So just very quickly, because I've just been given a bit of a wave in terms of the timing, but the circular economy model, this just highlights that opportunity for Narrogin in how we are able to obtain biomass from the farmers. We process it into renewable fuel. We're planning to do fertilisers as well. Goes back to the land, helps regenerate the land, and then we get more biomass. It's pretty exciting, really, as a model. What I am pretty excited about is this report. This was just released last week. We have an MOU with Horizon Power because they wanted to look at, well, what is the real benefit for a renewable diesel in the market? And is it something we should be supporting? So they had ACEL Allen do an independent economic report. And what ACEL Allen advised at the end of that report was a $20.4 billion boost to the Western Australian economy over the life of our pipeliner projects. We've got about 20 projects that we've got in the pipeline, but once you've got the foundation project up, you can scale it. And that's the exciting part. And that's in Western Australia alone. It'll be over 1,000 jobs. So it's a win-win. And this is why I'm so passionate about it, because this is projects that will be developed in most regions of Western Australia that will be a value add to those communities. But we're also doing this in the East Coast. So we've got projects identified in Queensland, and it does make a difference having support from state government. And I'd like to congratulate the Queensland government for the support they're providing for this sector, because it is going to drive players like us and many other international players to Queensland, and we're really excited to be a part of it. So we think collaboration is important. We've got some great partners in Western Australia. We've already got an MOU with the Shire of Hughenden. We've been looking, one of the opportunities is woody weeds. And given the small scale of our technology, if you've got a fisher trough, you've got to go for different types of feedstock, because it's hard to aggregate that kind of feedstock in an economic way. But when you're smaller, it's a lot easier to do. And that's what we're really excited about. So really looking forward to being on the East Coast as well. Very excited to be looking for partners. We're hoping to get to FID by Q1 next year at the latest, if not earlier. We've gone through EPA, development approvals, the FEED to get to a bankable feasibility study. We've done a lot, but we're still trying to finalise the offtake. So happy to talk to people about offtakes. We think it is competitive compared to the market, but what is the market? That's always a big question. And happy to discuss the project with anyone that would like to know more. Thank you.
Thanks, Jennifer. Well, a broad spectrum of projects in multiple geographies, different technologies. I think if you've got a question on a SAF plant, the stage here, including Pat, who's dialed in, can answer it. So I open the room to questions. And I might just start while we get a microphone to you. Paul, BP have built lots of projects, multi-billion-dollar projects around the world in oil and gas, now SAF. I mean, how much of the learnings from that are applied to SAF, and how much is new when you're looking at risk assessment and all the other things that go with project development to get it off the ground?
I'm not sure why you asked me first. We had other options here, but I'm going to quote Mike. I'm not an engineer, so big disclaimer here. But yeah, so absolutely lots of synergies, not only with our upstream projects, but also with our refinery experience. So we've got 5 refineries across the world, and we've got a global projects organization that actually is being deployed to execute our projects here in Kwinana. So we really leverage the global expertise of BP, the global expertise of major projects in the upstream, but also, and specifically our experience in the refinery space. And actually, we're bringing that capability here to Australia.
Thanks, Paul. Question? Yep.
I want to prioritize other people, but I ask...
You've got the microphone, so...
Okay.
Just give
so again, my name is Tatsukato from Sojitz. So we are one of the largest Japanese conglomerate investment trading house. My question to Paul and Jennifer. So Sojitz and other Japanese conglomerates operate many mining across Australia. So for example, we operate some of the mining in Queensland and Western Australia. And some of the decarbonization option for mining fleet may include electrification with a battery and hydrogen fuel and I guess renewable diesel. So could you briefly explain what would be competitive advantage or pros and cons for renewable diesel over hydrogen and the battery, and why Australia is a good place to produce renewable diesel? Thank you.
Okay, I'll have a go to that one. Yeah, we're working a lot with the mining sector around decarbonization options. And our view, and I think it's generally in the room, is there's not one option for decarbonizing the mining sector. And I think it's a lot of the conversation here is it's about bringing all the options, and each one of those options will have a different application. The reality, or our view from a BP perspective around timing, is that the only solution that you have today is renewable diesel. So it's the only available option that you can actually, as a drop-in fuel, as we discussed today, will really accelerate the decarbonization of the mining sector. We're doing, actually at the moment, a piece of work to understand all the energy vectors and the timing of each one of those and the application. And as I said, we believe renewable diesel, as you know, is available today, and we are doing some trials with BHP, actually, for a 20% blend and 50% blend in the Pilbara, and the trials have been very successful. But we're also looking at hydrogen for mobility, Now, as you would know better than I do, that technology is challenging, still not as scalable, and it's extremely expensive. But we're doing quite a lot of work on the back of some projects that have been announced for hydrogen, and hydrogen is one of our growth engines around how do we bring hydrogen quicker into the mining sector. But yeah, definitely not, we don't see that for the next 10 years. And then battery, there's challenges around electrification of the mining sector, as you would know better than I do. So yeah, renewable diesel, absolutely. Hydrogen is something that we see playing a role post 2030. And electrification, depending on the fleet, it will play a role, but renewable diesel, we see it as really, really critical today. There's also the argument that we talked about it earlier today, the renewal of the fleet, not only mining, but also in the transport sector. Mining usually, get their fleets and it lasts for 10, 15 years. So we can expect them to suddenly all turn the fleet around into hydrogen over the next 5 years. That's just not going to happen. When renewable diesel can be used today and used with the technology that the mining industry and the transport industry have today. So really critical for us to accelerate. But for that, if you haven't heard it today, we need the right policy settings to actually support the industry to really accelerate.
Thanks. Next question. Oh, sorry, Jennifer, go for it.
Can you hear me? Yes. So I think all the solutions are important. We're actually involved in green hydrogen and have supported electrification as well, and I think they're all important. They're all going to be needed to get to net carbon zero. I think it's looking at what's available and what are the economics of the situation. One of the reasons we're focusing on renewable diesel, the technology we're using can produce a green hydrogen as well, and a really good yield and very cost effective. But the renewable diesel we saw as the most competitive opportunity. So in particular sectors, we think it's extremely competitive, and we think it's competitive in the mining sector. I think it comes down to feedstock availability too, but in places like the Pilbara and other places, you can now create energy crops that don't impact food production. There's opportunities for that. So I think renewable diesel can actually play a really large role. Also, for those that don't want to do a capital upgrade of all their diesel usage equipment and transport, it's a way of actually transitioning without any additional capex. So it is an advantage from that perspective as well.
Hi, sorry, Neil Garton here from Jet Zero. Thanks for the great presentations. I actually had a very similar question, so I'm going to try and pivot slightly from that. Just building on the current economics of your projects, you can all obviously alternate the output from renewable diesel to SAF. So your current economics are based on the renewable diesel primarily, and then you see in SAF as an upside. Is that correct? And then building on that, as you start looking at second generation crops, is that factored into your economics now?
Flynn?
We're not a renewable diesel company, and we don't focus on renewable diesel, and that's part and parcel because of who our investors are. They all want SAF. And what's slightly unique to our process as well, so when we hydrocrack our syn crude, we get a product slate, with lights and heavies. The advantage is we have a gasification process, so when the light ends, we can cycle back to a gasifier, back into syngas, and the heavy keep cracking, so we come out with SAF.
So that's from a BP perspective. So we're not necessarily focusing on renewable diesel. So the way we're building Kwinana is to have the flexibility to swing between SAF and renewable diesel. We will get some yield of renewable diesel even if we go max SAF or the other way. So they will be definitely producing both. We do see demand today for renewable diesel on a voluntary basis, probably stronger than what we see of SAF domestically. But at the same time, from a value perspective, we see SAF export producing the most value for the plant. So it's kind of a mix. We are developing as much flexibility as we can in the plant, both from a feedstock perspective, but also flexibility around what can we produce in order to maximize the greater value for the plant. And as you know, very capital intensive, so we do need to give ourselves the most flexibility in order to make sure that we provide the right returns.
And I'd add, our plants could make 100% diesel if we wanted to. And so we would think exactly the same way. We'll go with wherever there's more margin to make money in the end.
Initially, we focused on renewable diesel because we saw the need for it in the market, and we felt that our project was competitive, which we still believe it is. But what is competitive is that question. We didn't think we had the choice of SAF because at that time there was no one that had gone down the pathway of certification down that SAF pathway. But then we were able to identify a partner that started that process. It does take, they say it takes 12 months for that pathway, but I think it does take a little bit longer than that. So for us to get to FID, we saw renewable diesel as being the quickest way to market. However, it has opened up the opportunity for us in terms of the project and the pipeline, because I think it'd be pretty exciting if we could get this project up by 2025. Show what's possible from a regional development perspective, and also be able to add SAF onto it as well. But it does come up to the additional cost. We've done some initial modelling on that, and it seems really reasonable. So it'll be a decision point for us whether we do move away from renewable diesel and go to SAF, or whether we stick with the renewable diesel at this stage, because that's what our bankable feasibility study has been done at this point in time.
Thanks. I think we've got a question out the back here.
David Evans, Defence Science Technology Group. I'll just make one comment quickly before I ask a question. Is the goal at ASTM at the moment is to do pathways in 3 years. So from the setting up of the task force to actual balloting is aiming for 3 years. And Patrick can tell you exactly how long it takes to go through that ASTM pathway, the 4054 pathway. So it's great that we're all talking about renewable diesel, because I think sometimes it's a missed part of all these forums. Trucks and ships aren't as sexy as planes, so that gets missed, but it's a big market. So my question really is around how, as a collective, as producers, do you actually understand, do you set up a specification guide for it? Because currently there's only the one specification outside the military who have highly specified the renewable diesel content. There's only one commercial one that's based in Europe, and it's based on essentially HVO and as a niche rather than blended. And we understand why we blended in the military, because of fit-for-purpose properties that have come from conventional petroleum that are understood, and that's why things like the Australian diesel determination are essentially not worth the paper they're written on when you're actually trying to develop a diesel fuel. So it's kind of, my question is, as a collective, how do we globally address that, noting that there's various different specifications, 975 and EN 590, and then our little sucker down here? How do we actually do that as a collective, where the aviation industry's got it all sorted, it's very well controlled, and they have OEM buy-in? And from experience, the hardest thing about the diesel side is actually getting OEM buy-in to accept it.
I won't answer directly the question. What I would say is we do have a team of experts, and we've got one of them here. And it does take a lot of our time, actually, to make sure that we work collectively. And we talked a lot about it today around how do we work together from a policy perspective, but also to set out the right frameworks in order to make sure that the bioenergy industry succeed. And policy and standards and clarity around those standards are absolutely critical. We spent 3 days as a team with BP over the last few weeks, actually, to really nail down what we need in order for this industry to be successful. And a lot of it was around the standards that we need and the clarity that is needed, not only for domestic production, but also to be able to give us flexibility around importation of HVO. So I'm not answering your question very well. What I'm saying is we absolutely understand the importance of it. We bring our global capability to be able to have those conversations, and it's absolutely one of our priorities to work with the government and to actually set those in order to get our industry to succeed.
I think your question is too technical for us, but to an extension to what Paul said, I think similarly standards around carbon accounting, CI, LCA, just as important. We're seeing there's certain standards all around the world, and the last thing we want to do as producers is have to have multiple certifications for the same gallon of fuel to sell to different customers.
From what I understand, this is being sold by the Australian government anyway, who's going to be developing a renewable fuel standard, which is fantastic. In terms of the fuel that we have, we've had it tested according to Australian standards. Density was the only area, like with any renewable diesel. But there are Section 13 exemptions, so that still enables us to utilise it here in Australia under those exemptions. But when the new renewable diesel standards are in, that will overcome that issue. What I do know is there's companies like Lendlease. We've got Abigail here if anyone wants to know about her experience about implementing it. But there are companies that are already implementing it. And if you want to understand some of the challenges in that, it'd be good to chat to some of those companies, because there are a few companies that are now starting to import it and using it on site and dealing with all those O&M related issues.
So mine is a question for Pat and probably Flynn. You're both operating in an environment that is heavily incentivised to be able to deliver projects. I guess my question is, what would it take to draw you out of that market to develop a project in Australia? Is it capital and incentives? Is it primarily incentives? And given the pipeline of projects that you currently have, how long you already signed up for before you would be looking to develop projects here?
Well, I'll go first, and then Flynn can. We're modularizing our plants. We're going to base it on 100 million gallons of ethanol input is one size, and then we're developing another that's 300 million gallons of ethanol input, and it would be an electric plant, because there's some sites here in the States that have nuclear energy, nuclear electricity, and that's a fine way of defossilizing ATJ. We're going to build these in a factory and then ship them to our sites. That's the plan. That's what we're working on in engineering right now. And that's for a bunch of reasons. It's de-risking stuff. And so it's actually pretty easy to do. So if someone wants to build a plant in Australia, we'd certainly cooperate, and we would bring axles with us. And in terms of the technologies, it's like I said, these are all extremely engineered at large scale. And we would do that. And then on the carbon accounting side, this is incredibly important. I think it was Flynn who mentioned it just a minute ago. It's a big deal. It is screwed up all around the world, and I think it's going to continue to be screwed up for a long time. So the only way that I see out of this is that we set up a systems of monetizing stuff in parallel with whatever the government does, because they can't, no disrespect to anyone. You know what? At least here in the States, governments can't be trusted. They change stuff. And so you got to have a plan to work around that. And so you've got to, I think ultimately we have to get to collectively, all of us, have got to get to something that consumers can see, recognize, touch, verify themselves, look it up, see where stuff came from with no game playing. That's what we have to get to. It's a long-range goal, I know. But that's what we have to do in the long run. Otherwise, people will just always say, no, someone's lying, someone's cheating, someone's doing whatever. So there's a lot of work in front of us, but it takes commitments to doing the measuring, reporting, transparent about whatever's happening with no game plan.
So
we would help come to Australia anytime someone wants to. We'd help set up a project. We did the feasibility work there a couple of years ago. We just haven't focused on it lately.
It's a hard one, right? Because you look at the level of support available in the US, and even before the Inflation Reduction Act with incentives, capital grants, all that sort of stuff. Our project in Sierra was the beneficiary of a $70 million capital grant from the US Department of Defense. On the revenue side, we get all the advantages of LCFS, RFS, other stacked incentives. And so it's kind of all of the above, right size for Australia to make Australia more attractive. And so, with what is available in the US at the moment, and now with the Inflation Reduction Act, it's, why would our board tell us to go develop projects anywhere else, right? We're going to get our best return in the US. So that's a challenge. Not to say we would love to do one here. With the right development partners, we could probably do one under a licensing model. But our development capital is really dedicated towards the US projects because of the support, but also because we have all the building blocks for fast project execution.
Yeah, and I would say, Shahana, it's that if someone said, hey, here's a way that you can make the investment returns that's good enough to attract investors, it'll happen. Of course, that does mean that there's got to be enough revenue coming in from that plant from somewhere. Someone's got to pay that bill, and that's the tough one. And so I don't know how that'll work in Australia and that is the issue there.
Hi, Jeff Bell here from Microbiology, and this is directed to Pat. very innovative project with lots of innovations going on in the US there. What do you see as the main risk, or what keeps you up at night that you consider might stop you from getting a project in the ground, up and running, on time and making you money? What's your primary risk? What do you see as the main bottleneck or hurdle to get across?
Well, the technology's been laid to rest. I think we have enough people. We're working in the capital markets right now, working to raise money, talking to lots of strategics and lots of big equity funds. In the diligence, the technologies get the box checked. That's straightforward. That's not where the issue is. The issue is, how do you value this project and how do you deal with the various risks? What's that feedstock risk? What's the risk of the fuel on a jet fuel basis? What's the risk of the green value? It's those kind of things that create the risk. And then that gives everyone a bit of pause because, for instance, in the IRA bill, they did a partial good idea in that they said if you get a 50 CI score or lower, you get 3 cents per gallon for each CI point of improvement. Cool. Oh, and then they said by CORSIA method. Well, CORSIA isn't actually a method. It's a policy framework, and it's undefined as to what it actually is here in the States, and it can be modified from country to country. And it has things that make no sense for the states that will not be accepted. And so that's the fight that's going on in the States right now. Well, it'd be nice to know what those economics are. And so it's stuff like that bugs me and keeps me up. It is all, the other one is, in the world today, it is an incredibly inflationary environment. So we're having to go, in the old days, out of turbine engineers loose, we'd had a plant built already. We could go do that. We have experience of it. We've done it in our past lives, and that team works for me still. Nowadays, man, if you're doing any kind of project financing, it's really tricky because you got to turn up with that EPC contract, lump sum turnkey type of some version of it. And what is it? How does it work? And everyone's really reluctant to give guarantees for things that are 3 years from now. So what does that mean? It means, we're having to modularize the heck out of it way sooner than I ever wanted to do it. But you know what? In the end, that's the right idea because I could make more than one plant at once if we wanted to. And so it's okay, and it'll be cost effective to do it. So we work through these things.
Thanks. Any other questions? There's one at the back. Anyone else got a microphone?
Last time it wasn't. Chloe Davison from Glaze Sustainability. I'm wondering what you're looking for from the demand end, from your customers, to whether it's de-risk the projects. So that might be aggregated demand, it might be multi-year contracts. What are you looking for?
Tell you what, I'll start with one. From Jet Zero's perspective, I mean, we're trying to get a project off the ground. It is certainty of offtake and demand. And I think, minimising the risk, not just for us, but everyone along the supply chain from feedstock to farmer, so that, no one is exposed to unnecessary risk with costs, particularly in an inflationary environment, like Pat just mentioned. So that's important. But it's also not just the economics, it's the policy that we're all aligned and pushing in the same direction from all angles to get things done. And I think, also ensuring that we have a full picture or engagement with all the partners along the supply chain downstream with both, not just in our instance Qantas, but also their coalition members and what they're after in the project, in addition to the environmental benefits, but also the social and the governance side of things. So that's how we look at it. Throw it over to you guys.
Yeah, I mean, I'd agree with that. Obviously, an offtake contract's really important when it comes to financing. But in our case, our offtake partners have also brought capital, which has enabled the growth of the business as well.
So with our project in Narrogin, it's the offtake that is our focus at the moment. What we are finding, there's a lot of demand in overseas markets, but because of our focus around a circular economy, we're really trying to support the local markets. But boy, it makes it hard when you don't have the regulatory regimes that we have in other parts of the world. And what I do love, I think there is a passion from buyers here in Australia, but they can't do something that's a competitive disadvantage. So I think, that just makes sense. We need to have regulations which support companies going down the path of lower carbon fuels. I think that's the only way we will really get more uptake here in Australia. And I think that will also bring more investment in Australia and make our life a lot easier, and because we don't want to be selling our fuel overseas, that's for sure.
Yeah, and just from BP perspective, maybe a slightly different. So we got part of the business is ABP, so we are one of the biggest jet fuel marketers globally. So when we look at global demand, we're pretty comfortable that there will be a home for the SAF that we will produce here in Perth. So obviously, as we said today, not the most optimal thing to do, but we're pretty confident that we've got the right customers in the right place with the right midstream infrastructure to take the product where the customers need them. Obviously, we would much prefer to put them here in Australia. So offtake, I think we evolved over the last when we first started this project, we said we absolutely need to firm the demand. Today, we're actually, it would be nice, but we're also comfortable that the demand is happening as we show you today from the BP outlook that we do every year. We know that decarbonization is happening global. We know what's happening in the US and Europe, and we know the SAF will be needed, and we can take it there. So feedstocks definitely is something that we are probably is more of a watch point for us, and making sure we've got the right feedstocks for our plants. And the third one is actually making sure that we can get this done. I think something that they said before, in the current environment, from an inflation perspective, supply chain constraints, capability gaps in this space, we really, it's a race to get this done by 2026. And we need to have, the right capability, the right tools in order to make it happen safely, obviously, and making sure that no one gets hurt on the way. So really focus on really execution of the projects and making sure we can do it in time, on budget, and safely.
I'll add one more thing then to this. We, in the long run view, if we want SAF widely adopted, there's a couple things that have to be true. No one individual airline can take it on at a premium and have their margins go down or their ticket prices go up. That'll drive business to other airlines. That's a problem. And so in the end, we ultimately have to get to some kind of a consortium thing where everyone's sort of accepting the price increases and adopting it. And you know what, though? They still got to be in somewhere reasonable. Otherwise, it will not be fast growth. It will not be large growth. It's going to be a niche product. Now, granted, that because the jet fuel market worldwide is at, 100 plus billion gallons, a tiny niche is still pretty big. But you know what? That doesn't really solve the problem and meet the customer demands. We've been meeting a lot of customers, the people who buy airline tickets, and teaching them about how these systems work and what to be looking for. And I think there will be some, I think they're going to be really, really important in this whole game because airlines can't afford to pay all the premiums themselves. That's why the government supportive stuff is good. Incentives need to be in play and all the rest. But if we're thinking big scale, going to make a difference and help move the needle on greenhouse gases, then we need it very, very widely adopted. That means it must be cost competitive and pretty much uniform in some way across the different airlines. This is a practical matter.
Thanks, Pat. Well, look, that was a great way to finish this session. Pat, thanks for dialing in for the US. I know it's late there. Appreciate it. Thanks for our speakers. Fantastic presentations. And we're all around if you've got any other questions. So thank you.